All right. Hey there, SRE Meetup. I'm sorry I couldn't be there live today, but I will be following up with a Q&A in the next week, so do pay attention, do take notes. I'm here to tell you a pretty compelling story around site reliability engineering, intersecting with cybersecurity and open source, to explain to you why mean time to update is the best metric you've never heard of. If you have not had a talk from me before, my name is Sal Kimmich. If you have heard a talk from me before, good to see you. I hope your error budgets are in the green, and I am a developer advocate at Sonatype. We are here to talk about exactly why there is a new wave of cybersecurity attacks, where the vulnerabilities are entering into your software supply chain, how versioning and open source herd behavior can affect best practices, and why mean time to update improves not only your architecture, but the global supply chain. So, if you are a modern developer, this is what your open source supply chain likely looks like. You are importing open source components from repositories, integrating that with your source code, containerizing it, and then using infrastructure as code to make sure that what we're building is reliable, reusable, deployable, and scalable. Uniquely, Sonatype is positioned to really understand what the behavior of both individuals, groups, and sort of entire ecosystems of developers looks like, because for over a decade they have been hosting the Maven repository. You may know this better as the Apache Central Maven repository, and they have been looking at what the relationship is between the contribution of an open source project, the versioning of it, and the behaviors of the developers that take in those projects. We do understand that as of 2020, over 90% of modern application components were being pulled directly from open source, which is a beautiful thing to see as terms of, human creativity and development. We are all working together, but it also means this. It means that we are often pulling from projects that are minimally or under supported, and we are relying on some large enterprise infrastructures to do that. So if I am talking to a group of SREs, I am very much preaching to the choir on this subject. But let's talk about what we can do to understand what these look like and how we might be able to prevent them from even getting into your ecosystem when you're looking at something that may be unsupported or will become a lemon in the future of your development. So, on the bright side, it looks like open source is expanding in ways that we've just never seen before. So even in the last year, we've seen C and Python a 92% increase in the downloads, and in most other major ecosystems, a 50 to 80% increase in the downloads. That means that people are not only reaching out, contributing, and developing more, but we are becoming collectively even more dependent on open source. And that means that a very small percentage in that exponential gain also do have malicious intent. And we have seen in the last sort of 5 to 6 years a 650% year over year increase in the next generation of software supply chain attacks. So what do I really mean if I'm saying next gen? You may be an SRE that works in a workplace where you have your team, there's a cybersecurity team, or maybe you work a little bit in tandem. But that just is meant to sort of take out vulnerabilities that you have already in your source code, right? You want to catch it before it's in your runtime. What if, and this is the case, the next generation of software supply chain attacks recognize that, and so instead they're going for the weakest chain in the link. They're finding ways to go directly into the open source projects that you are pulling in, and may in fact have, if you have a dependabot that does an automatic version update for you, they're looking at those opportunities to find easy ways into the infrastructure that you have. These are also incredibly intelligent actors. We'll talk about the specific examples, but this slide is just to demonstrate to you that they are going after the most common, the most popular repositories. So it is not the fact that you might just have a couple of components that are going stale and aren't really being updated or maintained. they're actually really going after the ones that are actively maintained because they can come in and get just a couple of hours of vulnerability over some major sort of architectures and get what they need out of it. So really do pay attention. It happens in the ones that you use the most. So the three biggest cybersecurity threats that we saw in the last year, uh, typo squatting was definitely one of the top of them. It's a pretty easy way for them to get an easy into your system. It's exactly what it says it is, right? It's a malicious actor putting up a project that is very slightly typoed off from what you intended to actually import, and then that imports something else. A great example of this is from 2021. This is just 2 months ago. There was a variation on the Python library matplotlib that was exploited in over 5,000 downloads, where instead of giving you matplotlib, you got crypto mining instead of scatter plots. Another really good example of this, if you want a more SRE relevant example, they do exactly the same thing with your Docker images. So they're looking for the places where you're not necessarily paying attention so that they can do an indirect attack into your system. Second was the dependency or namespace confusion. I think that these are really, really interesting. This is when a bad actor publishes a malicious package using the exact same name, but a newer semantic version. For a really interesting example of this, there was actually a white hat or ethical hacker that in February of 2021 was doing exactly this, exposing those that had this weakness and building in a sort of exemplifying what these namespace confusions were. The intention there was genuinely just to surface these vulnerabilities and get them fixed. However, this really tipped off those that were black hat hackers. And this ended up creating more than 10,000 dependency confusion copycats, which infiltrated the NPM and other ecosystems. So this created a huge cluster fire of vulnerabilities from someone who was just trying to improve the system. And I think this really speaks to, if you're not working right now directly inside of cybersecurity, why this is really different and why you have to think about developing differently when you're considering the balance between SRE and security. In SRE, we give ourselves the chance to burn down budgets because we just want an experience that works well for the end user, right? In cybersecurity, it does not make sense to have an error budget. As soon as you are aware that you have a vulnerability, you need to go in and fix it. You are always on pager duty. The longer that stays vulnerable in your architecture, the more likely you are to have greater damage. And then third are malicious code injections. So these are really sort of a variation of grabbing onto and taking sort of the lead on an open source project. So this is not typo squatting. This is genuinely someone going in and maliciously taking over an OS project, either by stealing credentials, releasing new versions, contributing pull requests that are problematic, or tampering with open source developer tools. A lot of the times when there are initial code injections, no one knows that it's there except for the person that planted it. The biggest example of this in the last 2 years has probably been the one from SolarWinds that you've definitely seen in the news. In December of 2020, there was a malicious code injection into SolarWinds, and this ended up trojanizing a sort of crypto exploitation and having new vulnerabilities introduced into National Security Agency, the Department of Treasury, NASA, and this wasn't caught for a couple of weeks, almost a couple of months. So really, really, really interesting case of the open source supply chain being incredibly well exploited by an intelligent actor in a way that wasn't detected by, let's just say it, the National Security Agency for quite a while. Now, if I've scared you, I'm sorry. I would like to step back and talk about what we can do to try to fix some of these problems, because if we are looking at these really as open source issues, it's not just individual teams that need to take care of this. We really got to deal with this on a global scale. But if you are on an individual team, then you're probably at some stage of the software supply chain management maturity. If you are doing any form of SRE, then you're definitely at least in the green, you're definitely in the control phase, but a lot of you are already in at least somewhat or aiming towards a monitor and measure. So we're not going to go into a ton of detail on supply chain maturity. That is its own talk, and I'd be happy to have it with you. But I want to talk about exactly how we want to think about choosing the right components and the right versions in order to have the best mean time to update. Um, this is a quick overview slide. If you are a developer, you know what the best practices are. Like, don't choose a malicious, a release candidate, a milestone. Don't choose something that is known to be vulnerable. If all else is tied, you want to go to the newest version. So dependent bots are generally very good practice. Um, but there's sort of a flip side of this. Just looking into, I believe this was an NPM. No, this is the Spring Framework, excuse me. This is looking at the behavior of all developers that were pulling from the different versions of the Spring Framework over the last couple of years. And this is really showing you what we sort of intuitively know, that the older a version is, the less likely it is to be maintained. Those are the things that you're going to see in red. Generally, anything that's sort of in the blue are things that may have some release issues, and anything that's green is the optimal version of that code base. So you'll see that this really green bleeding edge is where you want to be. That makes sense. That's where there's the most community attention. That's where maintainers are putting most of their effort. But very interestingly, I want to make one note that we found across repositories. On average, it's not actually the very newest version that is the likeliest to be least vulnerable. The least vulnerable is actually about 2.7 releases back from the latest version. So that's just a little bit of evidence to show that maybe there's a little bit of a feedback loop and churn at that cutting edge. So be careful when you're using dependent bots. You might just be unnecessarily opening yourself up to vulnerabilities where you could be a little bit more mindful and make the right decision with one that's just 1 or 2 steps back. And this is exactly what I was just describing to you, how a team makes migration decisions. And proactive teams, generally in this case, are making the decision to go from one major release that is known to be secure onto the next major release. This is what we're talking about when we refer to herd behavior in open source. Now, I'm sure that you're looking at this and you're saying, hey, proactive teams, optimal teams, I'm sure that's us. I'm really enjoying this talk, but I don't have much to learn here. And maybe that's true, right? Maybe you have done both the right macro and micro dependency decisions. You've chosen the right components, and you've also made the right decisions inside of the dependencies that that architecture takes in. But statistically, I am sorry to say you're probably wrong. We found that in a review of over 100,000 applications with more than 4 million component migrations, that the majority of the migrations that developers chose to make, even if they were on proactive teams, ones that would consider themselves very sort of cybersecurity aware, were not optimal decisions. They were somewhat imperfect decisions. They were subjectively optimal based on, it looks like this is what most of the community is doing, or there has been a maintainer update to it. But only like 1 in 3 of these decisions were actually optimal. And I think that there's a lot of work that we can do to make sure that we sort of change our practices in this, because this is both a like cybersecurity and SRE concern, right? If this is basically understanding what is the best version to take on that is not going to produce decay at a rate that I am unhappy with, right? So traditionally, we've had a couple of resources to do this, to sort of evaluate this holistically. You can lean on libraries.io's source rank, which tells you the sort of quality of a project, focusing on the documentation, maturity, and community into a single score. Generally around 30 is the highest that you can get. There's also the OpenSSF criticality score, which measures things like the community, usage, and activity into a single score. That's really meant not just to show how healthy the project is, but also how critical it is to the software ecosystem, like how necessary it is that that be maintained for other people to be able to lean on it. And today, I want to explain to you why we probably need to be moving to a new metric, which I'm going to call the mean time to update. So this is based on how quickly a project moves it's updates on dependencies. So in this case, lower MTTU is better. So that means it takes less time for them to update their dependencies when a vulnerability is found. And a higher MTTU is worse, right? That just means they're a little bit more lagging, they're a little bit slower, and anyone in the open source pipeline that's reliant on projects with a slower MTTU are putting their projects more at risk for vulnerabilities. So what exactly is MTTU? How are we going to calculate it? So for any given component, so this is a project that you have imported from an open source repository, we state that for a given component, we examine all versions of dependencies that exist for it. We calculate the time between when that version of the dependency was released and when component A releases a new version with the dependency update. And then we compute the average across all of the dependencies for that component. Now, I think this is a super cool way of looking at it, right? Because it takes out sort of the labor that we have to do around, is this essay ported? Is the community and the documentation around this really good? Really, what this is telling us is it's kind of like building an immune system into your open source, right? It's finding out where a project is responsive and close enough to real time so that vulnerabilities don't even get into the architecture, don't even get into the ecosystem, and don't come into your pipeline that you're reliant on. So it's important to note that while MTTU doesn't directly measure the speed at which projects fix publicly disclosed vulnerabilities, it strongly correlates to a project's mean time to remediate, which, if I'm talking to a bunch of SREs today, I think that's pretty important to us. And really the last note on this, if you want to look at the new 2021 State of the Supply Chain report, it really goes into a bit of detail around this. But we really do need to start thinking about finding ways that are more automated, that are quicker, that really rely on statistic normality, rather than looking at open source as, a community-driven system where we can go and look at the docs, really decide by, pull requests whether or not it's a good idea to use it in your architecture, because the entire open source world is accelerating. In less than a decade ago, it would take about a year to have a full version update for one of these major projects. As of 2021, it takes on average 28 days, and that's just going to continue to increase. That's because open source projects are accelerating. They have more contributors, they sometimes have more maintainers, and there is just a constant pressure because as you continue to build out open source projects and have contributors add new elements and features to them, that expands the surface area for cybersecurity attacks. So, naturally, you have to be able to improve the way that you are observing, scanning, and remediating any vulnerabilities in as close to real time as possible. It's very possible that if I give this talk in a year, that MTTU for the average open source project will be down to 2 weeks or maybe one. If that's the case, you really need to start thinking about how you're going to have automation in place to make the right decision when the scale of production is exponentially increasing. So today, we learned about why there's been an explosion of open source contribution in the last decade, why malware attacks in open source development have and will continue to exponentially increase because of that. I hope I also haven't really bummed you out about this because it's a really exciting place to be, right? Yes, there is a new wave of cybersecurity attacks, but that's only because we are seeing a level of human contribution to new knowledge that we have never ever seen before. Open source is becoming an incredibly cool place to be, and I'm really, really excited to see what this looks like in a good 2 to 5 years once we get some of this global organization together. You really want to evolve your open supply chain with vulnerability metrics for optimal decision making in mind. Find a way to get an MTTU metric into your dashboard. Get in touch with me if you want some help around implementing that. And I really want to clarify that we are all responsible for the maintenance of the open source projects that we rely on. We cannot evolve best practices for vulnerability detection unless we do that at an ecosystem level. So if you are dependent on any of these major ecosystems or any of the other major ones that we support through the open source index, then we really got to think about this at a global scale. So I hope you enjoyed this talk, but wait, there is a little bit more because I am aware that I'm talking to some SREs today, which means I'm sure I have some Kubernetes fans. I am running an event in about 2 weeks called the Bug Bash. This is a live, asynchronous, cooperative model where we are finding some of the top open source projects in given ecosystems. Remember, this is a case where we've got an open source project, a maintainer, and many thousands upon thousands of contributors that often contribute features, but not necessarily contribute back to removing any vulnerabilities on the systems that they're reliant on. So we are stepping in, we are working directly with the maintainers of major open source projects, and we're running these like isolated bug bash events so that we can get these open source ecosystems less vulnerable. We're running a bash at KubeCon October 11th to 15th. So if you are a Kubernetes, Golang, or Rust developer, then you probably lean on one or several of these open source projects from CNCF. I would encourage you to join and sort of participate. If you do participate in a bug bash, again, this is all just on the CNCF Slack if you're not live at KubeCon. You have the chance to actually win some free training from the Linux Foundation and a couple of other really cool perks from CNCF. So I really encourage this. And what's really, really cool about this is that it's not just one time like wham and bam bash where we're sort of getting rid of a backlog. This actually sets up a way for these open source projects to get clean and stay clean. So after they participate in the bug bash, we put a system into place that does a review on every pull request that's brought into these giant open source systems, and we make sure that we're catching at the very, very front of that open source supply chain vulnerabilities before they can ever even get into the project, into those repos, and into your architecture. So again, if you're interested in this, please do join. This is going to be fun. It's free. It's the Bug Bash at KubeCon, October 11th to 15th. You can join if you are a CNCF member. If you're not a CNCF member, it's free to join. Please do. If you have any questions around MTTU, the Bug Bash, what you can do to change the future for open source, get in touch with me on Twitter at Kimmich Compute and join us online or offline anywhere in the world for this Bug Bash on this URL, tiny URL, KubeCon Bug Bash. All right. Thank you so much. Again, I'm sorry I couldn't be live, but I think that this was a much more enthusiastic version of this talk than the one that I can give at midnight. And I really hope that you follow up with some questions. I will talk to all of you very soon. Thank you so much.